School of Management Studies IGNOU presents an audiobook on the course MMPC 008 Information Systems for Managers for MBA program. Block 4 Support Systems for Management Decisions. Unit 13 Data Warehousing and Data Mining. Part 2.
Metadata. Metadata in a data warehouse is similar to the data dictionary in the context of a database. It stores data about data in the data warehouse. Types of metadata. Metadata in a data warehouse falls into three major categories. 1. Operational metadata. As already discussed, data for the data warehouse comes from several operational systems of the enterprise. These source systems contain different data structures. The data elements selected for the data warehouse have various field lengths and data types. Selecting data from different source files and loading it into the data warehouse requires splitting of records, combining parts of records from different source files, and dealing with multiple coding schemes and field lengths. When information is delivered to the end users, it is essential to be able to relate back to the original source data sets. Operational metadata contain all of this information about the operational data sources that allow us to trace back to the original source. 2. Extraction and transformation metadata. Extraction and transformation metadata contain data about the extraction of data from the source systems, namely the extraction frequencies, extraction methods, and business rules for the data extraction. Also, this category of metadata contains information about all the data transformations that take place in the data staging area. 3. End user metadata. The end user metadata is the navigational map of the data warehouse. It enables the end users to find information from the data warehouse. The end user metadata allows the end user to use their own business terminology and look for information in those ways in which they normally think of the business. Special significance. Why is metadata especially important in a data warehouse? First, it acts as the glue that connects all parts of the data warehouse. Next, it provides information about the contents and structure to the developers. Finally, it opens the door to the end users and makes the content recognizable in their own terms. Metadata requirements. According to Inmon, a new user approaching a data warehouse wants to know what tables, attributes, and keys does the data warehouse contain? From where did each set of data come? What transformation logic was applied in loading the data? How has the data changed over time? What aliases exist and how are they related to each other? What are the cross-references between technical and business terms? How often does the data get reloaded? How much data is there? This helps end user to avoid submitting unrealistic queries. Given some means of determining the size of tables, technical staff can tell the end users, you can do what you like with 15,000 rows. But if it turns out to be more, then back off and ask for help. Metadata components. Warehouse metadata is not very different in kind from ordinary database metadata, although it is versioned in order to permit historical analysis. Prism gives the following breakdown of warehouse metadata in its tech topic: Metadata in the data warehouse. Mapping. The mapping information records how data from operational sources is transformed on its way into the warehouse. Typical contents are identification of source fields, simple attribute to attribute mapping, attribute conversions, physical characteristic conversions, encoding or reference table conversions, naming changes, key changes, defaults, logic to choose from among multiple sources, algorithmic changes. Extract history. Whenever historical information is analyzed, meticulous update records have to be kept. The metadata history is a good place to start any time-based report because the analyst has to know when the rules changed in order to apply the right rules to the right data. If, for example, sales territories were remapped in 1991, results from before the date may not be directly comparable with more recent results. Miscellaneous. Aliases can make the warehouses much more user-friendly by allowing a table to be queried by widgets produced by each factory rather than MF stats. Aliases also come in useful when different departments want to use their own names to refer to the same underlying data. Obviously, though, aliases can also cause a great deal of confusion if they are not carefully tracked. Often, parts of the same data warehouse may be in different stages of development. Status information can be used to keep track of this. For instance, tables might be classified in design, in test, inactive, or active. Volumetric information lets user know how much data they are dealing with so that they can have some idea about how much their queries will cost in terms of time and computational resources. Volumetrics could usefully include such information as number of rows, growth rate, usage characteristics, indexing, and byte specifications. It is also useful to publish the criteria and timescales for purging old data. Summarization and aggregation algorithms. As discussed above, a typical data warehouse contains lightly and heavily summarized data and aggregations as well as full detailed records. The algorithms for summarizing the detailed data are obviously of interest to anyone who takes responsibility for interpreting the meaning of the summaries. This metadata can also save time by making it easier to decide which level of summarization is most appropriate for a given purpose. Relationship artifacts and history. Data warehouses implement relationships in a different way from production databases. Metadata pertaining to related tables, constraints, and cardinality are maintained, together with text descriptions and ownership records. This information and the history of changes to it can be useful to analysts. Ownership or stewardship. Operational databases are often owned by particular departments or business groups. In an enterprise data warehouse, however, all data is stored in a common format and accessible to all. This makes it necessary to identify the originator of each set of data so that inquiries and corrections can be made by the proper group. It is useful to distinguish between ownership of data in the operational environment and stewardship in the data warehouse. Access patterns. It is desirable to record patterns of access to the warehouse in order to optimize and tune performance. Less frequently used data can be migrated to cheaper storage media, and various methods can be used to accelerate access to the data that is most in demand. Most databases do a good job of hiding such physical details, but specialized performance analysis tools are usually available. Some general-purpose tools, such as Information Builder's Site Analyzer, also are available. Reference tables or encoded data. Reference data is stored in an external table and contains commonly used translations of encoded values. The contents of these tables must be stored in order to guarantee the ability to recover the original uncoded data together with effective from and effective to dates. Data model design reference. Building a data warehouse without first constructing a data model is very difficult and frustrating. When a data model is used, metadata describing the mapping between the data model and the physical design should be stored. This allows all ambiguities or uncertainties to be resolved. From the point of view of the query manager of the data warehouse, the metadata repository can be perceived to have three logical layers: the information navigator, the business metadata, and the technical metadata. The query manager accesses the metadata through the information navigator layer, which is the topmost layer of the metadata repository. The higher layers, in turn, access more detailed metadata components resident in the lower layers whenever required. Data Warehouse and the Web. Professor Peter Drucker, the senior guru of management practice, has admonished IT executives to look outside their enterprises for information. He remarked that the single biggest challenge is to organize outside data because change occurs from the outside. He predicted that the obsession with the internal data would lead to being blindsided by external forces. The majority of data warehousing efforts result in an enterprise focusing inward. However, the enterprise should be keenly alert to its externalities. As markets become turbulent, an enterprise must know more about its customers, suppliers, competitors, government agencies, and many other external factors. The changes that take place in the external environment ultimately get reflected in the internal data, but by then it may be too late for the enterprise. Proactive action is always better than reacting to external changes after the effects are felt. The conclusion is that the information from internal systems must be enhanced with external information. The synergism of the combination creates the greatest business benefits. The importance of external data and the challenges faced in integrating external data with internally sourced data was discussed in the section on Load Manager above. In the same section, it was mentioned that some externally sourced data is often distributed through the internet. Reliability of web content. Many question the reliability of web content, as they should. However, few analyze the reliability issue to any depth. The web is a global bulletin board on which both the wise and foolish have equal space. Acquiring content from the web should not reflect positively or negatively on its quality. Consider the following situation. If you hear, buy IBM stock because it will double over the next month, your reaction should depend on who made that statement and in what context. Was it a random conversation overheard on the subway, a chat with a friend over dinner, or a phone call from a trusted financial advisor? The context should also be considered when judging the reliability of web content. The interesting aspect of the web is that information resources occupy all quadrants. In the upper center, the commercial online database vendors traditionally have supplied business with high-quality information about numerous topics. However, the complexities of using these services and the infrequent update cycles have limited their usefulness. More to the left, governmental databases have become tremendously useful in recent years. Earlier, public information was often available only by spending many hours of manual labor at libraries or government offices. Now, facilities on internet are available to provide valuable and up-to-date data via the web and virtual databases. Public organizations, governments, business houses, educational institutions, and other industries realize the importance of data also with regard to right to inform, and hence up-to-date data and information is required to be maintained as obligatory requirements of the user community. At the left, corporate websites often contain vast amounts of useful information in white papers, product demos, audios, videos, and press releases, eliminating the necessity to attend trade exhibits to learn the latest and greatest in a marketplace. Finally, the doubtful quality-free content occupies the lower half of the figure. Its value is not in the quality of any specific item, but in its constantly changing diversity. Combined with the other web resources, the doubtful quality-free content acts as a wide-angle lens to avoid tunnel vision of the marketplace. Web farming. Like operational systems, the web farming system provides input to the data warehouse. The result is to disseminate the refined information about specific business subjects to the enterprise sourced from the web. The primary source of content for the web farming system is the web because of its external perspectives on the business of the enterprise. As a content source, the web can be supplemented by the intranet web of the enterprise. This content is typically in the format of internal websites, word processing documents, spreadsheets, and email messages. However, the content from the intranet is usually limited to internal information about the enterprise, thus negating an important aspect of web farming. Most information acquired by the web farming system will not be in a form suitable for the data warehouse. Also, as discussed above, the source and quality of the content need to be judged. In any case, the information must be refined before loading into the warehouse. However, even in its unrefined state, the information obtained from the web through the web farming could be highly valuable to the enterprise. The capability to directly disseminate this information may be required via textual message alerts or What's New bulletins. Refining information. When a data warehouse is first implemented within an enterprise, a detailed analysis and re-engineering of data from operational system is required. The same is true for web farming. Before web content can be loaded into a warehouse, the information must be refined. The process of refining information consists of 4 steps. 1. Discovery. Discovery is the exploration of available web resources to find those items that relate to specific topics. Discovery involves considerable detective work far beyond searching generic directory services such as Google or indexing services such as Alta Vista. Wikipedia is another such service. There are many more known as search engines to dig out data and information from the World Wide Web. The discovery activity must be a continuous process because data sources are continually appearing and disappearing from the web. 2. Acquisition. Acquisition is the collection of maintenance of content identified by its source. The main goal of acquisition is to maintain the historical context, such as in Wikipedia, so that you can analyze content in the context of its past. A mechanism to efficiently use human judgment in the validation of content is another key requirement. 3. Structuring. It is the analysis and transformation of content into a more useful format and into a more meaningful structure. The formats can be web pages, spreadsheets, word processing documents, and database tables. As we move toward loading data into a warehouse, the structures must be compatible with the star schema design and with the key identifier values. 4. Dissemination. It is the packaging and delivery of information to the appropriate consumers, either directly or through a data warehouse. A range of dissemination mechanisms is required, from predetermined schedules to ad hoc queries. Newer technologies such as information brokering and preference matching may be desirable. Online Analytical Processing (OLAP). In the previous sections, we have discussed the need for building an enterprise data warehouse, followed by discussions on its structure and ways and means of populating it with data. The data warehouse serves as the memory of the enterprise, but memory is of the little use without intelligence. The tools that analyze data provide the intelligence. In this section and the ones that follow, we discuss some of the tools available for accessing the data warehouse and transforming the data in it into information useful from the point of view of the business or business intelligence. The term Online Analytical Processing (OLAP) was coined by E.F. Codd in 1993 to refer to a type of application that allows a user to interactively analyze data. Online Analytical Processing (OLAP) is a method of analyzing data in a multidimensional format, often across multiple time periods, with an aim of uncovering the business information concealed within the data. OLAP enables business users to gain an insight into the business through interactive analysis of different views of the business data that have been built up from the operational system. This approach facilitates a more intuitive and meaningful analysis of business information and assists in identifying important business trends. OLAP can be defined as the process of converting raw data into business information through multidimensional analysis. This enables analysts to identify business trends and weaknesses, business trends and the underlying causes of these trends, It provides an insight into the business through the interactive analysis of different views of business information that have been built up from raw operating data, which reflect the business users' understanding of the business. The OLAP application contains logic, which includes multidimensional data selection, subsetting of data, retrieval of data via the metadata layers, and calculation formulas. The OLAP application layer is accessed via a front-end query tool, which uses tables and charts to drill down or navigate through dimensional data or aggregated measures. Although OLAP applications are found in widely divergent functional areas, they all require the following key features: multidimensional views of data, calculation-intensive capabilities, and time intelligence. The OLAP engine, which is comprised of the analytical processing logic and the data processing logic layers, provides a front end to the data warehouse, an interface through which a variety of general-purpose graphical user interface or GUI type tools can make access the data warehouse. This arrangement makes the data warehouse data available for non-multidimensional analysis as well. The four major types of OLAP applications are multidimensional OLAP, hybrid OLAP, desktop OLAP, and relational OLAP. Multidimensional OLAP is based on a multidimensional database architecture. This stores data in a three-dimensional data cube that is already in the OLAP multidimensional format for slicing and dicing into analysis views. Relational OLAP products are designed to operate directly on a data warehouse built on a relational database through a comprehensive metadata layer. Hybrid OLAP products primarily integrate specialized multidimensional data storage with relational database management technology. This allows businesses to link multidimensional data to the underlying source data in a relational or object-oriented database. The desktop style of OLAP allows user to perform limited analysis directly against data held within a relational or object-oriented database while avoiding many of the problems that affect hybrid and relational OLAP styles.
We were listening to the audiobook by the School of Management Studies IGNOU for MBA program, course code MMPC 008, Information Systems for Managers. Course Coordinator, Professor Anurag Saxena, School of Management Studies IGNOU. Voiceover by Renuka. Edited by Uday Sharma. Program assisted by Jagbandhu Jana. Program produced by Dr. Manoj Kumar Singh. This program was brought to you by Electronic Media Production Center of Indira Gandhi National Open University.